Managing Machine Learning Projects Assignment, Duke University. Opportunity Evaluation. Problem: a taxi company needs to grow profit against expensive overhead costs. It needs to identify lucrative, busy locations for its taxi drivers to pick up customers from. So, for example, from popular sports stadiums. The opportunity is looked towards using machine learning to identify lucrative locations and match taxi drivers to them. Leverage data patterns from social media, weather, news, together with historical taxi transactions and GPS of the current taxi. The problem, if nothing is done, a taxi company will continue to struggle with over-assigning burned out drivers, risk losing their licenses, and the taxi company itself also risks losing their operating license and also missing out on lucrative rides. Machine learning provides an opportunity here because it could utilize its clustering abilities to locate profitable locations. Business understanding. Target user will be the taxi company owner itself, so you can identify how many drivers it needs to assign, and also the taxi drivers themselves who are paid on commission to identify which are the best rides to take. Why it's important: non-optimal driver assignment erodes profit, missing out on lucrative rides, and also for compliance reasons, for not to overuse drivers. Current solution is that we use historical schedule information, and we just assign all the drivers that we have. The gaps in this current solution is that it got excessive driver assignments and drivers are not in the right location at the right time to benefit from those lucrative locations. In terms of outcome, look towards increased monthly profit, and output is to make sure that we have a good performance from the clustering algorithm in terms of measuring the low intra mean square errors and then the high inter location cluster distances as well for profitable locations. In terms of solution validation plan, the hypothesis is that taxi drivers would use the recommendations of lucrative locations when they appear on the mobile app. To validate this, we would run a series of experiments to collect feedback and satisfaction from taxi drivers and customers for the location recommendations. We would conduct a series of experiments increasing in sophistication from basic wireframes and using piped data of 3 manual fed locations, and then move to more sophisticated real-time data. In terms of the ML system design, we need to make 3 decisions: whether we go with cloud versus edge, or offline learning versus online learning, or whether we go with batch predictions or online predictions. So for this taxi solution, we look towards using cloud because we need to collate many data sources, and look towards using online learning to keep the data model updated with new data as it arrives, to identify location clusters based on profitability. And in terms of online predictions, because the drivers need to make real-time decisions on which locations to base themselves, we would need online for this. Potential risks in production that we have is training skew data, so we need to make sure that we have represented data from live and for training. Data drift, we need to make sure that we need to take considerations potential seasonal fluctuations or public transport strikes that could induce spikes of demand. We need to make sure of concept drift in terms of customer behavior, which might change. For example, when people are remote working, there'll be less demand for taxis for commuting. And we would introduce various post-deployment measures like we're showing here to overcome those limitations. Thank you.